Alright, here's another video for 3HT about the next paragraph, 9.5, counting with and without repetition. So first thing I'd like to say is that we're going to skip this tree diagram. It's not interesting at all. And we have network diagram. Well, you can read it if you want. But I'm going to be talking about the multiplication rule. Here's a whole example. You can read that if you want to. But I'm going to show it to you using this example. This is exercise 46. So let's talk about that exercise. It says Jordan turns the spinners shown in figure 9.24. After the spinners have stopped turning, each arrow points to one sector. The result is a 4-digit number. In figure 9.24, the result is 1515. You can see that the points here are the 1515, so you get 1515. It could also be, for example, 2146. For example, that could be a different number. So you can make a couple of numbers. The question A is actually how many different numbers are there possible? So how many can you make using this? So let's write that down, A. And now we're going to use the multiplication rule. So I'd like to explain what it is. You have to multiply all the different possibilities that you have. So here you have 4 different possibilities. Here you have 5 different possibilities. Here 4 and there 3. So it's going to be 4 times 5 times 4 times 3. Yeah, so you don't look at the highest number, you look at how many things there actually are there. If you calculate this is 20 times 12 is 240. So there are 240 different numbers that you can make using this. Question B, how many even numbers are possible? Okay, to make a number even, you only have to look at the last digit. Because if you have 4135, it's odd. But if you have 4136, it's even. So this one decides if it's going to be even or not. So these numbers don't decide anything. So we can use all of them. So we're going to use 4 here. 4 times 5 times 4. Now this one's going to be different. Instead of 3, it's now going to be 2. Because we can't use that 5. Because if you use that 5, it's not even anymore. So we have this, and then you get 160 different numbers are possible to make there. Question C. How many numbers greater than 2000 are possible? Okay, so here we have all of these. This one decides the thousands, right? This is 1236, for example. Now it needs to be greater than 2000, so this needs to be at least a 2 or a 3 or a 4. So there we have 3 possibilities, and then these don't matter, because if this is going to be a 2, it does not matter what you put behind it, it's going to be greater than 2000 anyway. So you're going to have 3 times 5 times 4 times 3. So this is 15 times 4 is 60 times 3 is 180 different numbers are possible to make using this that are bigger than 2000. Question D. How many numbers are possible if the last 2 digits need to be the same? So these two need to be the same. So if this is a 1, then this also needs to be a 1. But there is no 1 here. There is only 1 digit that they have in common, and that's a 4. So it needs to be 4, 4. What these are doesn't matter. So it's going to be 4 times 5 times 1 times 1. It's going to be 20. So you can make 20 different numbers that end with 4, 4. Question E. How many numbers less than 1400 are possible? So it needs to be less than 1400. That means that this cannot be a 2 or a 3 or a 4. Because if it's going to be that, it's going to be already bigger than that. It needs to be a 1. So we have one option here, which is a 1. So this 1 does not mean that it was the 1. It means the number of options, which was 1. And then this needs to be lower than 4. Because if it's going to be a 4 or a 5, the number is going to be bigger than 1400. So it needs to be this, that, or that. So 1 times 3, and then here we have 4 options. It doesn't matter what you have there, and it does not matter what you have there. So 3 times 4 times 3. So this is going to be 36. So we have, this is what we have. 240, 160, 180, 20, and 36. So this was the video. Thank you for watching, and I'll see you next time.